Section 6.3 is going to continue this idea of parallelograms, but notice the title. It says proving quadrilaterals of parallelograms. So yesterday we gave you basically that we had a parallelogram, and that meant, okay, so opposite sides were parallel based on the definition. Opposite angles were congruent, opposite sides were congruent, all those different things.
All those properties, right?
All those different things, exactly. Now, basically, we're going to kind of, in a sense, flip that. So I'm going to give you some of those different things. Like if I gave you opposite sides in a quadrilateral were congruent, then you could say it's a parallelogram. So
it kind of sounds like the converse of some of the theorems that we've already
exactly right. So you'll notice this one right here, I've kind of, in a sense, we've kind of filled in the blanks so that way this goes a little bit quicker. It says, if both pairs of opposite sides of a quadrilateral are congruent, and we kind of mentioned this a little bit ago, then the quadrilateral is a parallelogram. So notice down here, if I give you the opposite sides are congruent, so AD is congruent to segment BC, and segment AB is congruent to segment DC, well then this is a parallelogram.
Okay.
It's exactly the converse of what we learned yesterday.
And one thing just to mention too, we also know that the opposite sides are parallel, but that's by definition.
Exactly.
And we talked yesterday about the definition, and definitions work the same way forward and backwards.
Exactly.
So just something to be aware of. The definition still works if we know opposite sides were parallel. This is using those other reasons that we came up with.
Now, notice there's no name again, and so this is sometimes the issue. You can't just say, well, the reason is because opposite sides are congruent, because we already have a theorem that says that. So what would be, how could we use this as a reason if I ever explained it? What do you think?
So could I say opposite sides are congruent converse?
We could say that. What do you think?
That would work.
Okay. So these are, again, the converse. All right. So knowing kind of what you're dealing with here. So just saying the reason would be the opposite sides are congruent converse. Okay. Or you could basically say it in words. You could say if we have these, then it means a parallelogram. It just depends on where you're going with it.
Okay.
All right, so you'll notice basically all of these are converse from yesterday.
All right. This next theorem that we see, it says if both pairs of opposite blank of a quadrilateral, and I'm going to give you this one. So we've already talked about opposite sides, so what do you think we're talking about?
Opposite angles.
So opposite angles of a quadrilateral. And what did we learn about those opposite angles?
They were congruent. So if I gave you those were congruent.
If we know that those are congruent, then we do know that this will be a parallelogram. So again, notice that I've got down here, if we knew that angle A and angle C were congruent, and we knew that angle B and D were congruent to each other, then we know that, yeah, this has to be a parallelogram. And since we said opposite angles were congruent is kind of our theorem, we could say opposite angles congruent.
It's the converse.
So it's just flipping. It's saying that now we're proving this is a parallelogram. Kind of like when we proved lines parallel, we used all the converse theorems. Same idea. We're proving all these things to be parallelograms, so we're using these converse of these.
Perfect. So you're like, yeah, when you're proving parallelogram, kind of like when you're proving parallel. Good. All right, let's move on to another one. Okay, so help me fill in the blank. It says if an angle of a quadrilateral is blank to both of its consecutive angles.
Okay, well, when we talked about consecutive angles, we talked about them being supplementary.
So if we know that they're supplementary to, notice it says both of its consecutive angles here, then we know it's a parallelogram. So if you look at this example, it says if angle A is supplementary to angle B and D. So if I left off this part and just said angle A was supplementary to angle B, would that be enough?
I guess not, because that's probably not, which would make sense because that wouldn't require the other one to also have to be supplementary. Exactly.
Well, and the thing is the key, we kind of talked about this yesterday. This is similar to, like, you could apply this idea of the consecutive interior angles theorem idea. So if I only gave you these are supplementary, that would only really prove that these are parallel, right?
Right.
Which doesn't prove these are parallel. So you do need to have both sets, and that can kind of get confusing, all right? So if angle A is supplementary to angle B and D, you need both of those pieces. Or if I said angle B is supplementary to angle C and angle A, It's just as long as you basically need two sets of supplementary angles.
Okay.
Just like on the last two, you needed two sets of congruent angles, or two sets of opposite sides are congruent.
All right, this next theorem talks about the diagonals, and we learned something about the diagonals yesterday. We talked about the diagonals had to do what?
They
did end up doing what?
Yeah, if I had a parallelogram, then the diagonals bisected each other. So if I know that diagonals bisect each other, then we know it's a parallelogram.
Exactly. And if you look at this one, we can see that we're saying that AE was congruent to EC, and that BE was congruent to ED. Kind of did that backwards. But if I know that those diagonals are bisecting each other, then I know that this is a parallelogram. So same ideas. And again, we could say diagonals bisect each other converse.
Perfect. All right, I think we have one more. This one's not a converse of what we talked about yesterday. It's a new one. So technically, if you think about it, we have, to prove something is a parallelogram, we could use the definition. We could use opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary. We could also use the diagonals, bisect each other. Another way, so there's lots of ways. That's
right,
lots
nice. Of ways.
It says if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So there's two different scenarios because you're talking about one pair. So let's say you're talking about AB, side AB, and side DC. So these sides are congruent and parallel, then that's enough to prove that's a parallelogram. Or the other sets. It just depends. So this one's kind of nice. And this was one I think people forget about sometimes.